Hello auditors, welcome to OpenZeppelin's Ethernaut AlienCodex challenge. Over here you can see that this is the smart contract, and in order to solve this challenge we have to claim ownership of this challenge. Let's dive into the code. You can see that this is the code that I've copied and I've just modified the importation. So instead of following the import of this particular directory, I actually created my own directory. So what this is actually a simple OpenZeppelin dependency package, where this is one of the dependency package. So what we can do is basically we can just set our owner variable, transfer ownership, and so on and so forth. Okay, and over here we see that we understand that this is actually an inherited contract of ownable, and we notice that this is particular owner address which is stored as slot 0. So I've actually created a comment over here which this is actually slot 0. And since there's no other state variable, we can just ignore this contract. Now let me further explain how this works. So if you guys understand delegate call, my challenges that where I stated that all the slots we can just go back there and watch the video, but anyways I'll just give a brief summary. So over here is address, which is 20 bytes, so it's at 20 over here, and the second state variable is boolean, so it's actually just 1, so over here got 21 bytes. And next we got this dynamic array. So what dynamic array is actually a simple array that we can actually do not really need to specify the size of the array now. So let's just move on. Over here you can see that at this particular solidity documentation, the array data is located starting at this stack 256, and different storage slot is computed using stack 256 hash. So what this means is that the dynamic arrays, the slot stores the number of elements in the array. Exception and arrays and strings are an exception, or we can just ignore this. So the main gist of this particular documentation is stating that the length of the array is actually slot 1 first. So over here we got 32 bytes, and then afterwards the elements of the array, let's just call it k of stack 256, we just call it k1, and then k2, so on and so forth. And this is how the storage slot works. So moving on, we can see that this is actually a simple modifier, and this actually just set the contact equals true. So this modifier actually just check whether contact is true, and this function uses this modifier, so this particular contact must be true in order the function to work. It actually just push or append an element to the array. And then we got this particular interesting function which actually retracts. So what this does is actually similar to popping an array. And the funny thing is, you might not be familiar with this particular syntax. It is because we are actually using 0.5 version of Solidity and not 0.6 and above. And then lastly, we got this function which actually takes a uint and then also a byte, and this can actually specify the array index and element. So moving on, you actually notice that since it's 0.5 version, it is actually possible to perform an underflow. So what this means is that 0 minus 1, it is equals to 2 power 256 minus 1, which will give us a large sum of number. So what this means is that the last slot, just move this here, okay, move this here, this will be k and that 2 power 256 minus 1, then so on and so forth. Now let me just remove this particular drawing. So in order to solve this challenge, we actually can just perform this simple step. Firstly, we get the slot 0 by performing the underflow, and then after getting the index position or the storage location, we can actually specify our own address. Thus, we will actually convert this particular owner to us. So let me just reiterate again. Firstly, we get the slot location, and then we pass the slot location at this function and specify our address, thus stealing and claiming ownership of this particular contract. So how do we interact with this contract? firstly I'll actually create a simple interface for us to interact. So you can see that over here, firstly we make the contact true so that we can able to play with this particular function. And then we will perform this underflow, which actually just particularly just get the slot 0. And then afterwards we can just minus it and then call the position. So I'm just going to run the script and I'll pause the video now. Okay, you can see that we have actually successfully completed the challenge, the storage size and the first position. So after minusing, you'll get this 0 position. So this is where this storage is, the slot is. And then over here, you can see that the owner has been changed to us. So I've actually submitted it to MetaMask. You can see that we have completed this challenge. So if you guys like this video, please hit the subscribe button and the like button. Thank you for watching and have a nice day.